Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Mickey 17 by Arctan. And I guess this is in reference to the movie that came out fairly recently called Mickey 17. Um, and here are the rules, and it sounds like it's very similar to what the movie is about. Normal Sudoku rules apply, which means fill every row, every column, and every box with the digits 1 through 9 without repeats. And there are 17 cages in this puzzle, and the digits in each cage sum up to 17. No multiples are allowed, so they add up to exactly 17 for every cage. So these 4 digits add up to 17. These 3 digits add up to 17. These 2 digits add up to 17. These 4 digits add up to 17, etc., etc. Digits may not repeat within a cage, and no 2 cages may contain the same set of digits. As an aid to the solver, the possible sets for the cages are 8, 9, 179, 269, 278, 359, 368, 458, 467, 1259, 1268, 1349, 1358, 1367, 1457, 2348, 2357, and 2456. So those are all the digits in the cages that are possible. All the combinations. And again, you cannot have a repeat of the digits in a cage either. So every single one of these cages actually has to contain these sets that Arctan laid out. So you have to have one cage that's 8 and 9, one cage that's 179, one cage that's 269, etc., etc. Because there are 17 cages in total, and I guess there's 17 different possible permutations for those cages. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And I think this is because I believe in Mickey 17, a small spoiler alert, I think it's in the trailer, so I don't even know if it's a spoiler. But there's multiple of this person named Mickey, and they're essentially clones, but they're all slightly different. So therefore, you can't have, and I think there's 17 of them, I guess, which is why it's called Mickey 17. But basically, there's 17 of these clones, adding up to 17, but they're all slightly different, right? There's none that's exactly the same as each other. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. Now, I'm going to get started. Let's go. Okay, first things first, we have a 2-digit number that adds up to 17. It has to be 8 and 9. It also means the 4-digit cage in it cannot have an 8 or a 9. Well, there's a decent amount of possibilities there, so we don't know what that is. We also have, so let's fill in the remaining possible digits. Well, okay, one thing we do know is 8 and 9 cannot be in column 1 in box 1. So one of the 8 and 9s at least has to be in this 3-cell cage. But you cannot have 2 of them there because they would already add up to 17 if that were the case. So only one can be here. So only one out of the 8s and 9s can be here. And the other 8 or 9 has to be here. Okay, I'm not sure what that tells us. Let's see. Do we have anything else we can make? Again, one of these has to be 8 or 9, and one of these has to contain an 8 or 9, but none of them can contain both. Let's actually mark the 8 and 9s possible, or singular 8 or 9, with green. So, well, this is both 8 or 9. So, but let's mark this. This is one 8 or 9. this is 1, 8, or 9. We'll mark ones with 0, 8, or 9s as red. So this is red. This could have an 8 or 9 here, or 8 or 9 here, or an 8 or 9 here. Oh, that's interesting. How many 3-cell digits can have an 8 or a 9 in them, or cannot have an 8 or a 9 in them? Only one, right? You have a 179, a 269, which 359 all require 9. We have a 278, 368, and 458, which all require 8. And then the last one's 4, 6, and 7. So one of these has to be the 4, 6, 7. The other ones must contain an 8 or a 9. So this is this is specifically then 4, 6, 7, 8, 9, 4, 6, 7, 8, 9, and 4, 6, 7, 8, 9. And none of these can be 8 or 9. Because we know one of the 8 or 9s has to be here in one of these 3-cell cages. Another one has to be in another 3-cell cage, and the last one's 4, 6, 7. So these have to be 1 through 7. So this cannot be an 8 or a 9 either. So this is not an 8 or a 9. Obviously, these can't be 8 or 9. That means these have to contain an 8 and 9 because all the 3-digit, the non-8 and 9 3-digit number is already taken by one of these 3 cages. So 8 and 9 has to be one of these, and then the other one has to be here. So therefore, these must contain one single 8 and 9. Oh, that actually helps a lot. So basically, if this were the 8 and 9, that would eliminate all possibilities for this cell. And it would have to be 4, 6, 7, but we already have a 4, 6, 7 here, if that's the case. So this cannot be 8 and 9 and 8 and 9. Therefore, this must be an 8 or 9. So this requires 1 here specifically. This is 1, 8, or 9. This is 1, 8, or 9. So this cannot be 8 or 9 because 1, 8, or 9 is here, 1, 8, or 9 is here. So this can't be 8 or 9, which means this is the 8 or 9 in this cage. Okay. So that means 8 or 9 has to be one of these two. We're not sure which. So these cannot be 8 or 9 also. So one of these two is. None of these can be 8 or 9 because, again, one of these has to be 8 or 9. This has to contain 1, 8, or 9. And therefore, none of these can be 8 or 9 here. Okay. How many 4-cell cages require an 8 or 9? Not many, right? 1, 2, 3, 4, 5. Oh, 5 out of 9. So I guess that's still a majority. Huh. So one of the 8 or 9s is here. One of these has to contain an 8 or 9 because 8 or 9 cannot be here. And one of these has to be 8 or 9. So this has to have 1, and this has to have 1. So that's 2. We don't know about this. Okay, we know both of these add up to 17. That makes the rest of this add up to 11. So it's either 137, 146, 236, or 245. It's kind of broad, actually. So that's not very helpful there. Oh, this is interesting. This is 17 here. this is 17 here. Okay, so this is 17 and this is 17, which means these three add up to 11. These three also add up to 11. I don't know what that tells us. So this is at most 10 here. These add up to 17. Oh. There's only one 8 or 9 here, so this has to actually contain an 8 and 9 in these 4 cells. Right, this is 10 at most, so this would be 17. Oh, that's very interesting. This is 17, this is 17, this is 17. So that's 3 times 17, which is 51. This is 10 at most, which means the remaining digits are 90 minus 51 minus 10 at most, which would be 29 at least here, which means this is 5, 7, 8, and 9 at minimum. So this is 5, 7, 8, and 9 at minimum. So this cannot have a 7, and it cannot have 8 and 9. So this could also be 6 and 9, 6, 7, 8, 9. So this has to be 1 or 2 here, right? Because this is at most 10, and it can be at least 9 because this is at most 30 here. So you have 30 plus 51 in these 3 cages. That's 81, which means this is at least 9. So if this is 1, that means this is 10. So if this is 1, this could be 3, 7, or 4, 6. If this is 2, it's 3, 6, or 4, 5 here. Okay. Therefore, we know 7 has to be one of these 3 cells. So this cannot contain a 7 here. And 7 cannot be here either, because we know one of these is a 7. So this is 1 through 6. So these both cannot contain a 7. So we can remove any 8 or 9s with a 7, but there's none anyways. So we already kind of knew that. Oh, that's interesting. I didn't really know that, but... the 7 could be with 9. Or the 7 could be with 4 and 6. I guess the 7 could be with 2 and 8 too. So I guess this could be 4, 6, and this is 7. That's possible. Okay. So there are 1, 2, 3, 4, 5 4-cell cages, which could have an 8 or a 9 here. We know we have 1 here and 2 here. Oh. These 2 cages add up to 34. So these 2 cages must add up to 11. So it's either 2, 9, 3, 8, 4, 7, or 5, 6. Okay, that doesn't really tell us much. This cannot be 1 and 2 here. Because if this is 1 and 2, then it would have to be 1, 2, 1, 2, and 8. Because we know this adds up to 11. So the 1 or 2 has to be one of these. And this has to be also... Oh, that's actually very interesting. If this is 1, this has to add up to 10, but this has to add up to 10. So this would only add up to 7. Okay, so let's figure this out. If this is 1, this has to be 3, 7, and 4, 6, and this is 3, 7, or 4, 6, which would force this to be 2, 5, to add up to 7. If this is 2, they both add up to 9, right? So this is 9 and this is 9, because again, these add up to 34, these add up to 34, so this must be add up to 11, and these three must add up to 11. So if this is 2, it's 3, 6, and 4, 5, and this is 3, 6, and 4, 5. So therefore, this adds up to 9, which would force us to add up to 8. So this is 1, 7 here, if that's the case. That's actually very interesting. Hmm. Hmm. Oh, that's interesting. If this is 2, the problem is 1 would have to be in one of these 3 cell cages, adding up to 17, and 1 would have to be in one of these 3 cell cages, adding up to 17. But we only have one unique 3 cell cage which contains a 1, which is 179. So that's not allowed. So this has to be specifically a 1 then, which makes this, again, has to be add up to 10 here, has to add up to 10 here. So this adds up to 10, which means this is 61 in total, which means this is 29. So this cannot be 5, this cannot be 6, 7, 8, 9, it's 5, 7, 8, 9. So the rest of the box cannot contain 5. And this rest of row 3 cannot contain a 1. So we have 2 in one of these, which means we also have 2 in one of these 3 cell cages, which means 1 and 2 cannot remain in any of the remaining 3 cell cages. So this cannot be 1 or 2, because actually it could be 1. Cannot be 2. So one of these is a 2. Actually, one of these 3 is a 2. Because we have a 2 here, and we have a 2 in one of these. We're not sure which. But 1 does actually have to be in one of the 3 cell cages, and one of them has to be here. Cannot be here, cannot be here, cannot be any of these, and therefore that's 5 already taken. So 1 has to be one of these, which means it must be with 1, 7, or 9, but we're not sure which one it is. So this cannot be 1, 7, or 9. It has to be 2, 3, 4, 5, 6, and 8, but this can't be 8, obviously. So 1 has to be one of these cells, because 1 can never be here and 1 can't be here. Therefore, 1 can't be here and 1 can't be here because of these ones, so this has to be a 1. So we have a 4 cell cage that has 1 with 9 or 1 with 8. That's still pretty diverse. This is 8 or 9. If this is the 2, 6, this has to be 9. If this is the 2, it has to be 2 with 6 and 9, which would force this to be 8. The 7 can't go with anything anymore. except for 4 and 6. So this would be 4, 6, 4, 6, 7. So this would be 6. Okay, so if this is 2, it's 2, 6, and 9. Which would force this to be 4, 6, 7 here. So if this is not 2, if this is 4, 6, 7, this is 4, 6, and 7, right? It can never be 4 and 6 here with something else here. So this would be 4, 6, 4, 6, 7. It could be 2, 6, 9. And what are the other possibilities? 3, 6, 8. It can never be 3, 4. So I think this is always 6 here. What are the possibilities? Can't be 1, 7, 9. Can't be 2, 7, 8. Can't be 3, 5, 9. Could be 3, 6, 8. Cannot be 4, 5, 8. Could be 4, 6, 7. So it's either 2, 6, 9, 3, 6, 8, or 4, 6, 7. So 6 is always here. So this is 6, which means none of the rest of the row can be 6. None of the rest of the box can be 6. Therefore, this cannot contain a 6. So if it's 2, it's 2, 7, 8. It could be 3, 5, 9. Okay, if this is 7, it could be 2, 7, 8 here, which forces this to be 4, 6. That's fine. 4, 6, 7. Or this is 4, 7, and 6. So can this ever be 4 here? No. If this is 4, that would require this to be 6, 7. But that's not allowed. So this is... okay. What are the possibilities here? Obviously, no 179, no 269. It could be 278. Okay, so let's open up the possibilities here. So 2, 7, and 8. This can't be 5, so this would be 3, 5, and 9. Cannot be 3, 6, 8 anymore because the 6 can't be here. And if this is 6, this has to be specifically 4, 7. 4, 5, 8 works. So this could be 4, 5, and 8. And 4, 6, 7 works as long as this is the 6. So it would be 4, 7, 6. So these are actually very limited for what this can be. Interesting. We know there's a 6 in one of these cells. That's interesting. 6 has to be one of these cells. And it has to be with 8 or 9. So it's 1, 2, 6, 8. Oh, that's the only possibility. It has to be 6 has to be with 1, 2, 6, and 8. Therefore the 9 would be either it cannot the 9 has to have a 1 also. So it'd be 1, 2, 5, 9 or 1, 3, 4, 9. So it could be that this is 6 and 8 here. Or 6 and 8 could be here. Huh. We also know 5 is here, actually. Okay. So if this is 7, so say it's 4, 6, 7. 4, 7, 4, 6, 7. This has to be 3, 5, and 9. That works. Or if this is 5, this is 4, 5, 8, which would force this to be 2, 7, 9. Can this ever be 4, 5, 8? I guess 2, 7, no. Okay, so this has to contain a 5 or 7, and it cannot be 1. So it could be 278. It could be 359. It cannot be 458 because then this would have to be 7 and 2 and 8, or 7 and 4 and 6, which is not allowed. So this cannot be 458, and it cannot be 476. Okay, so this is either 278 or it's 359. Okay, so 4 has to be one of these. So the 9, okay, so the 8 has to be with 6, because that's the only one it can be with. So it's 1, 2, 6, and 8 to 4 with the 6 and 8, because 6 can never be with 9 to add up to 17 with 4 digits. And the 9 has to be with a 4, because there's no other place for the 4. So this one of these is a 4. This cannot be 4. So either this is 1, 2, 6, 8, or this is 1, 3, 4, 9. And then this would be essentially 1 and 2. Oh, this has to be not 1, 7, it's 2, 5. So this would then be 1 or 2 with 6, 8, if this is 1, 3, 4, 9. Or this is 1, 3, 4, 9 here. Okay. Actually, we don't know about this one. This is actually not correct. Because if this is 1, 2, this has to be 1, 3, right? So 3 could be here, and 2 could be here, and this could be 4, 6, 8, 9. We just don't know. One of these has to be 179. If this is 179, that would mean this is 6, and this would have to be 8. So if this is 179, that means this is 6, this is 8. Because you can't have a 7, 9 here, and you can't have 9, and this would then be 8, which would mean this can't be 8 or 9, so this would be 6. So that would require this to be 4, 6, 7, and this to be 8. What? 3, 6? So if you had 179 here, this is 8, this is 6, this is 9. So this would be 4, 5, 4, 7, 6. This would be 8, 3, 6. So this would be 4, 7, 3, and 6. This would have to be 2, 5. But that doesn't add up to 17. So this cannot be 179 here, which means this has to be 1, 7, and 9. This can't be 9 then, which makes this an 8. This 8 cannot be with 3 and 5. It has to be with 2 and 7. So this is 2 and 7, which means none of these can be 7. This has to be a 5. These can't be 2. This has to be 1 and 2 then, which forces this to be 6 and 8. So this is 6 and 8. This has to be 1, 3, 4, 9. And this can't be 1. This can't be 2 because of the 1, 2 pair here. So this can't be 2. So this is 5, which makes this a 2. This can't be 5. This cannot be, it could be 4, 5, 8, but then that can't be 8. So therefore it cannot be 4. It's 3, 5, and 9. Therefore this has to be 4, 6, and 7. So this is 7. This has to add up to 17 without 1, 7, or 9, and no 2 either, because this is already 2. We have 2, 7, 8, 3, 5, 9, 4, 6, 7, 1, 7, 9. I think 4, 5, 8 is the only remaining one that could fit that situation, because it can't be 2 here. There's a 2 here, one of these two. So it cannot be 269. We already have 179. 278's already taken. 359's taken. 467 is taken. So it's either 368 or 368 or 458. Or 458. So either way, 8 cannot be here. We actually kind of already knew that, actually. This can't be 3. So 8 either way is here. That means... Okay, what are the remaining ones? It has to be 2, 6, and 9, which means this cannot be 6. So this is 3, 7. This can't be 3, 7. There's no more 3s then in this 3 set. So this has to be 3, 6, and 8. Right? Because this can no longer contain a 3. So no 3 in 6. This can't be 2 or 5, so this is 4, which means this can't be 4. This can't be 4. This is 3, 6, 8. Remaining digits here. So it's 4, 5, and 8, but this can't be 4, 5, 8 because the 4 is here. So this has to be then 2, 6, 9. So this is 2, 9, and 6, and this is 4, 5, 8. Well, 4, 5, and 8 eliminate out of 2 digits adding up to 11. 3, 8, 4, 7, and 5, 6. So this has to be 2 and 9, which means this is a 9 and this is a 2. This can't be 2 anymore. This is a 5. So we have 4, 5, 8 here. This is 9. This is 2. This has to specifically then be 1, 3, 6, 7. So we have 1, 3, 6, 7, 2, 3, 5, 7 here. This is 4 digits without a 2 or a 4. And it must contain no 2, 4, 6, or 9. And it must contain a 5 to add up to 17. So it has to have 1 out of 7. Well, okay, it has to be 1, 3, 5, 8. So this is 1, 3, this is 8, and this has to be a 7. So this can't be 9, this is 8, which makes that a 9. Oh, well, there you go. So 1, 3, 5, 8 here. This cannot be 7 here, and this can't be 6 here. The remaining digits here are 1, 2, 4, and 5. And this is 1, 2, 4, 5, but this cannot have a 1 here. So this specifically is 1, 2, 4. That doesn't work with anything. It could be 1, 2, 5, and 9, but it can't have a 9, so that doesn't work. So that rules out all the 1, 2s. So then if we try, then we could have 1, 4, 5, and 7, and that does work. So this is 1, 4, 5, 7. That's the only possibility because we know the 1 has to be here because of the 1, 3 pair in row 4. So this has to be a 2, which means this can't be 2. This is 1, which makes that a 2. This can't be 1 anymore. This is a 7. These can't be 7, and these can't be 7. Therefore, we know this is a 7 for the remaining digit. This can't be 7, so this is 3, which makes that a 7. That's 3 in the corner. We celebrate because we know we're getting close. This can't be 3. So one of these is a 3. 8 is one of these two. 8 is here, so 8 has to be one of these 3. So this 4-cell cage has a 2 and an 8, which means the remaining digits must add up to 7. So it's either 1, 6, but we already have a 1, 2, 6, 8, so that doesn't work. And the only other remaining one is 3, 4. So this has to be 3, 4, and 8. Not 8, 7, 8. This can't be 3. Where is the 3 in this cage? It has to be here. So this is a 3. This is 3, 4, 8. This is 7. Remaining digits in this column are 1, 4, 5, 6, 8. The remaining digits in row 4 are 4 and 5, and this can't be 5, so this is 4, which makes that a 5. These can't be 4 because of the 3, 4, 8 triplet in the column, so this must be 9. This can't be 4 or 9, so this is 1, this is 4. This can't be 9, so this is 8, which makes this a 6, which makes that an 8. This 6 means this can't be 6, so this is 4, this is 6. These can't be 8. This can't be 8. This can't be 1. The remaining digits in row 6 are 2, 3, and 6. And this can't be 2 or this can't be 3. This can't be 3. Where's the 3? It has to be in this cell. So this is a 3. Remaining digits in column 6 have to be 1, 2, 7, and 9. And this cannot be 2, 7, or 9. So this must be 1, which means this can't be 1. Which means this has to be a 1. This can't be 1 anymore. This has to be 2, 7, or 9. Okay. Remaining digits in column 5 have to be 5, 6, 7, 9. Because it cannot be 2, because one of these is a 2. Okay. If this is 9, the problem is this is at minimum 1, 4, and 5 then. Which is 10, so that's not allowed. So this cannot be 9, so this is 2 or 7 here. We have 1, 3. Okay, so for the 4 cell cages, we have not used 1, 2, 5, 9. We've used 1, 2, 6, 8. We've used 1, 3, 4, 9. We've used 1, 3, 6, 7. We have used 1, 4, 5, 7. We've used 2, 3, 4, 8. We've used 2, 3, 5, 7. So we have only 2, 4, 5, 6, and what's the last one? We have 2, 4, 5, 6, and we have 1, 3, 5, 8 left. Well, there's no 3 here. So this has to be 2, 4, 5, 6, right? Again, we've used 1, 2, 5, 9. Actually, we don't have 1, 2, 5. Okay, that was the one that I was missing. So we have not used 1, 2, 5, 9. We've used 1, 2, 6, 8. We've used 1, 3, 4, 9. We have not used 1, 3, 5, 8. We have used 1, 3, 5, 8. Okay, that was the key. So we require 1, 2, 5, 9 left, and 2, 4, 5, 6. So either way, this has to be a 2 then. So this has to be 2. We have to have a 2 remaining in this cage too. So it's 1, 2, 5, 9, or 2, 4, 5, 6. Either way, it cannot contain an 8, so these cannot be 8. This can't be 8. This can't be 8. Well, where's the remaining digit where 8 can be? Can't be here, can't be here, can't be here, because we either have 1, 2, 5, 9 or 2, 4, 5, 6 as the remaining 4 cell cages. So this must be an 8, which means these can't be 8s. 9 cannot be here, so 9 has to be one of these two, which means this is the 1, 2, 5, 9. So this is 1, 5 with 1, 5, 9, which eliminates 1, 5, and 9 from the rest of the box. Therefore, this can't be 1 or 5. This can't be 5. This is 2, 4, 6, which makes this a 5 here. Therefore, this can't be 5, which makes that 4. This can't be 4, which makes that 3. This can't be 4, which makes that 6. This can't be 5, so this is a 1 or a 9. This can't be 6, so this is 4. This can't be 6, so this is 8. This can't be 8, so that's 3 or 6. This can't be 4. These can't be 5. These can't be 3. This can't be a 4, so this is 8, which makes that a 4. This can't be 4, 8, so this is 5. That can't be 4, 5, so it's an 8. 3 cannot be here. This can't be 2. This can't be 7 or 9, so this is 6, which means this can't be 6. Therefore, we have a 7, 9, 7, 9 pair in row 9, which eliminates 7 and 9 in the rest of the row. So this can't be 9, cannot be 9, which makes a 1, 5, 1, 5 pair in the cage, which means this can't be 1 or 5, so this is 9. This remaining digit is a 3. This can't be 3, so this is 6, which makes that 3. This 6 makes this a 4, which makes that a 6. This 9 makes that a 5, which makes that a 9. This 6 here makes this a 2, which makes that a 6. This 2 means this is not a 2, so this is a 7. 2, this can't be a 9 because of that 9, so this is 7, this is 9, which makes that 7, which makes that 9. This can't be 4 or 5, so this is 1, which makes that 5, 4. This can't be 1, so this is 5, 1. None of these can be 1. And this can't be 7, so this has to be 3. That makes this 6, 1, 7. This can't be a 3, so that's 1 and 3. And we've solved it. Pretty cool, actually. Pretty nice use of the premise of Mickey 17, where everything adds up to 17. And then you also have 17 different cages, all of which are slightly different. Very cool. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.